Hello, hi guys. Uh, Today we will be discussing on some concepts related to strings. Uh, these will be used as tools in solving some problems related to string-based questions. So we will start our discussion. So first thing I want to discuss with you is uh, we will try to learn how to reverse a string. Yeah. Um, so here is the thing. So I want to reverse a string. So for example, if my string is, consider my string as um, something like this. So that is in the given input. I want the output should be something like T, R, V, S, L, and P. So I'm just trying to reverse a string. So we can do one thing. Um, so every string, so the my string here is considered something like is an character array. The considered string has length 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. So what I will be doing is, so I'm putting this string into an character array. So where the first one is P, L, S, V, L, S, V, R, and T. So we can do something like we can take another array, character array of the same length as an input array, input string. And so if I'm going to take the same length, so it should be something like 1, 2, 3, 4, 5, and 6. So now what I will be doing is I will be putting, like I will be iterating through this first input character array and putting the last character in the first, and putting the second last into the second, and third last into the third, and this into this, something like here I am putting T, R, V, S, L, and P. So now this will be our output. So but the issue here is we are trying to take the considering the space complexity here, we are trying to take one more new in one more new character array. So we are taking an extra space here. So I want we want to discuss something like I just want to modify the existing character array or the existing string only without taking any extra space. I want to reverse this. So for doing this, I'm just making use of like two pointer technique. So how it will look like is, let me show this to you. Yeah. So here is my input character array. So what I will be doing is I'm just putting the index for this. This is the 0, this is 1, this is 2, this is 4, this is 3, this is 4, and this is 5. So what I will be doing is I'm taking two variables, I and j. Okay. So the starting point of I will be at index 0, and starting point of j will be at index 5. So what I will be doing, I will be traversing, like I will be traversing in this direction, in the right direction for the I, and traversing j in the left direction. So when I am traversing I in this direction, I am incrementing I. When I am traversing j in this direction, I am decrementing j. So the moment it reaches in the middle, I am just stopping the loop. So if you consider, so for each iteration I'm going to increment the I. So when I is at index 0, j is at index l minus 1 or length minus 1, or you can consider as at index 5. So now what I will be doing, I am taking a temporary variable and putting the value of p into that temporary variable and swapping that, like it's an it and swap, and in that character array of 0 I'm putting this value of t, and then in the character array of index 5 I'm putting value of p. So that's how I'm going to do it. So when you look at it, um, so when I is 1, then j is something like 4. When I is 2, j is 3. The moment the I is the moment the j is the moment the I will be greater than j, I'm just going to break the loop. So suppose for the next iteration, I will be 3 and j will be, we are decrementing j and j will be 2. So at this time, I'm just breaking the loop. I'm just putting this in the code here. So void reverse string. So what I will be doing here is I'm just considering the input as a character array. Okay. So the main purpose of doing here is I am not taking any extra space here for reversing a string. I'm just making use of the existing character array, and just by using a two pointer technique, I keep traversing through the character array. So what I will be doing here is I'm taking int and initializing it as 0 and int I. The same way I'm taking j and initializing it as 0, and here I'm just taking a for loop where the moment I am traversing until I is less than j, the moment I becomes greater than j, the loop will break out. And here I'm incrementing the I and decrementing the j. So the swapping logic here is, so here I'm just taking a temporary character t and storing the input character array of I of at index to that, and what I will be doing, and I'm just putting that, I'm storing the last index value to that, and for s of j I'm just storing that temporary character this. So I'm just returning this, then the output would be some like reverse of a string. So even if the same logic, so here the length of the string is 1 2 3 4 5 and 6, it is even. Even this logic will work for odd size arrays as well. So if I want to take an array of input character array of length 5, 1 2 3 4 and 5. So if we mark at the index 0 1 2 3 and 4, so initially the I will start here and j will start here. The moment the I becomes 1, at the same time the j becomes 3, and the moment then in the next iteration I will be 2 and j will be 2, which in this case, which is breaking our condition, it will just skip the loop. So basically here the element at the index 2, which is the middle element or the middle character, there is no need to swap this because it's the middle of the middle character of an array. This is how we can reverse the string. So if we look at it, the time complexity for this is, if we consider the length of the string, length of the string as L, technically we are just making an iterations, or the we are running our logic for around uh, half the length of the given input character array. It would be L by 2, so it would be, technically you can say as big O of n, or big O of, yeah, big O of n by 2, and technically it is big O of n. This is how and here the main purpose of taking this two pointer approach is I'm not taking an extra space the space complexity will be decreased when considered to the first approach, like the first approach, the traditional way, where we are taking an empty array of size equal to input character array, and then we are just copying the elements there. This is how we can do this. Coming to the next thing, so the next thing would be, the question is, given a string and rotate the string by k times. So this will be our question. Yeah. So for example, consider something like, um, the input string is A S D G T H B W. So this is the input string, and this is the input string given, and k is given as 3. Now the output here I am expecting is, take the k characters of the input string, that is from h, the 3 characters from the last, it would be from h, b and w, and do a right shift of this, and now the output I'm expecting is h, b, w, followed by this string a, s, d, g, t. This is my string. This is the output I'm expecting. So we will try to, so void rotate string. Here I have been given a character array and int k. These two are the inputs for me. So I'm expecting a string something like this. We will discuss how we can solve this problem. We will try to discuss first approach here. Yeah. So if we look at it, the input is a character array or a string where A, S, D, G, T, H. I'm just running out of the space here. I will try to draw from here. It is A, S, D, G, T, H, B, W. So now what I want is, so I want the last k characters to be rotated to the right of the string. So I just want to be the same order. So so last 3 characters are these. So now I'm expecting an output of H, B, W, followed by this string A, S, D, G and T. So technically we can do this uh, by making use of a substring here. So what I will be doing is, I'm taking a substring of length 3 from the end, and I'm taking this as a first part, and I'm taking the L minus k. So L is considered as the length of the string, L minus k as the length of the other substring, and just concatenating two strings and returning out the output. So and here we can look at it, we can have a look at it, like if the k is something like so if k is 3 or 2 or k is something less than the length of the string, then there is something we can rotate it. So if k is considered as the length of the string, suppose here the length of the string is 8, 3 4 5 6 7 8. So if k is given as 8, so then the output should be the same as input only. So when we are doing a rotation which is of length L, when we are rotating this, when we are doing a right shift of length L k times, where k is equal to L, then obviously uh, the output is same as the input is same as output. Both should be same. So here the k, if the k something like the k will be given as it should be something like if I want to know what should be the output if the k is given as 20 or if the k is given as 30. So here a simple math will work out to know, like, because in this 20, every 8 times I am just doing a right rotation, the input is same as output. So I'm not considering the, so I'm just dividing this by the multiples of 8. So if I divide this by 8, it should be something like 8 is 16 and it should be 4. So that means the two times when I'm doing a rotation of each 8, the output should be same as input, and the rest of the remainder is 4. So the technically just I need to do a rotation of 4 times. That means I will be considering THBW and just taking this as a substring and taking the other part as a second part of second substring and concatenating the first part with the second part, which is our output. So we can make use of modulo operator here. So here my approach will be, so I'm taking L as length of an here here I'm taking L is equal to length of the string. Now I'm considering K as K modulo L. So this will return out the actual number of times uh, where we need to rotate or doing right shift of the given input string. So this will hold good for everything. So if we are in this case, if k is equal to length, then the output is same as input. So after this, what I will be doing is take take k length substring from end and call it as first part. Next, what I will be doing here is take take L minus k length substring from beginning and call it as second part. Now what I will be doing, return first part plus second part. This will return out the required output for this string. So let's discuss about time complexity and space complexity for this approach. So here what I am doing is taking the k length. Suppose in the given input, the length of the input string here is 8 and k is considered as 3. Now what I will be doing in the second step, I am just the taking k length, that is 3 length of the substring starting from the end. So it will be something like h, b and w, and storing it in the first part, and taking the l minus k, that means like length is 7, and subtracted 3 is subtracted from the 8, length is 8, it would be 5, and taking the first 5 indexes, or like the first, I'm taking a substring of 5 and just putting in the second part, and I'm concatenating the first part with the second part. Here, if we calculate the time complexity, it will be around 2L. That means 2 times the length of the given input string. So this, how it is becoming 2L means, we will go step by step. So here, like calculating the modulo technically takes one time, and it's a one time operation. And coming to time complexity of this, taking k length substring from end and call it as first part. So I'm taking h, b and w here. So it will take k times. So how it is taking the time complexity of this is k times means, so in order to get the substring from the given input string, so technically in Java, substring will just the substring will return a new string. And how it is calculating the substring means, internally it is taking an array only, it is taking a character array and just going through one at a time. So technically the string is divided into character array, and it will take the h as a starting index and followed up to the end of the string. So if k is equal to 3, then it will start from l minus k. So if you look at it, so the length is 8, and the length is 8 and k is 3. 8 minus 3 would be 5, and it will be starting from 5, 6 and 7. So coming to the indexes, it is always one time less than the length of this. So it would be 5, h is at 5, and it will append b, character b, to the substring, to the existing substring of h, and the total output will become hb, and it will iterate, and it will get the character at this index and append that to hb string, existing hb string, it would be hbw. So we are iterating around k times for getting this first part, and for getting this second part, so it should be L minus K. L minus K times we are looping it to get the substring. And for concatenating, it has to go through each and every character of the first part, and it has to go through each and every character of the second part, and it is returning the output. So it should be technically the number of operations here, number of operations we are doing here is around, it is equal to length of the string L. So when we add these two things, L minus K plus L, it is around 2L. So the time complexity would be 2L. Come to the space complexity. So for space complexity, if you look at it, every time I'm so here I'm making a substring, and in step 3 here I'm making one more substring, and step 4 here I'm making one more string. So every time when we are creating a substring, it will take a memory to create a substring. So here one time, two times and three times. So we are doing it like So the space complexity would be something more than one time. So now we can better think of a solution where we can achieve this, like we can achieve this output by decreasing this space complexity. I don't want an extra space for this, because here I'm creating a new string as a part of creating substring. Here I'm creating a new string as a part of creating substring. And here I'm creating one more string. So technically it is taking three spaces in order to get the result of this question. So we will think of another approach where the space complexity should be less than this approach. So we will discuss on another approach. Approach 2. So in this approach, what I would like to discuss with you is, so if you look at it, so the given input is A, I'm trying to decrease this one. A, S, D, G, T, H, B, W. So what I will be doing in the first step is I try to reverse this string. So we already discussed the approach of reversing a string. So this reversing string of with time complexity of big O of n will be used, or big O of L will be used here in order to solve this problem in a better space complexity. So here when I reverse a string, all the characters will be reversed. Now the output will be W, B, H, T, G, D, S, and A. So if you look at it, the required output for me is H, B, W, A, S, D, G, and T. So when I reverse a string, this is the output I am getting, and this is the actual output which I need. So this is the output which I need. If you carefully observe this, there is some kind of operation we need to do on this part of the string, on this part of the reverse string which we got in order to get our required output. So if you observe this, what I will be doing here is I'm taking this part and I'm doing a reversing again, and I'm taking this part and doing a reverse of that again. So reversing of this first part will be, I'm sorry, just this was something wrong. Okay, yeah. So here is the thing. So this is the output. This is the thing which is this is the string which I got for the first time. I'm reversing the entire string, given input string, and this is my expected output. So if we carefully observe this, as k value is 3, this is one thing, and this is another thing. Yes. So if I am again reversing this first part, I am achieving this like H, B, and W when I am reversing the first part from this. And when I'm reversing this part, I'm just getting A, S, T, G, and T. So here I'm doing two things, like we will try to discuss the approach here. First thing is write a function to reverse string. where the input parameters it is going to take is a character array, comma, int start, comma, int end. So from this, by making use of this approach to return a reverse of a given input string, we can definitely write a function which will take as an input which will take an input array of input character array of strings, and here we are providing the start index and end index as well. Initially, like here we are not putting that those two parameters here. I am considering like it's a string, and technically it is starting like I and j. Sorry, here the j should start from length minus 1. So actually here I'm just decrementing the j should start from the last index of the given input character. So that's why I need to take this. And here I'm explicitly passing. I can definitely write a function by making use of the same two pointer technique approach, where I will be passing the start and end index of that string or the character array which I want to reverse it. Once that is done, then the output I have is the entire string. I have like I will be having entire string as WBHTGDSA. After that, I'm just again calling the same reverse string function by changing this input parameters. Like here, the start index would be start and end index would be different. And same thing again, I am calling the same function which I have defined with the new input character array as this, with the new input character array as this, like the second part TZDSA, and just changing like start and end index. I'm just changing for that. So if you look at it here also, I'm trying to calculate the k modulo length, and then if k is equal to the length of the given in character array, k is equal to length, or k is equal to 0, then there is no need to rotate anything more. So I can just uh, return the given input value. Else what I will be doing is I am calling this reverse string function with three things. One thing is I am calling with the given input only. I'm calling with given input, and for the first time when I want to reverse my string, so what I'm considering this whole string as my input. So here the s holds the whole string. Okay, now so the start index would be definitely it will start at 0, and the end index will be length minus 1. So now this will return me an output of WBHTGDSA. Now what I will be doing is I am again calling that reverse string function on the same character array S, but now my start and end indexes would be different. So it will be starting at 0, because now I'm just trying to reverse this part of the string only. So I'm trying to reverse this part of the string. So now the start index would be 0 and end index would be k minus 1. So because technically this w is at, so here we have like k is equal to 3, so w is definitely at index 0 and b is at index 1, h is at index 2. So I'm starting, so I want to reverse this string, so my start index is at 0 and end index would be 2, which is equal to k minus 1. So that will return an, so now the output of the string is, so now we got an output where the first k characters are reversed. So it will be h b w, and rest of the things we are not doing anything. So it will be h b w and t g d s a. In the next step, what I will be doing is, here again I am calling this reverse string function with the same input character array. Yes, now my start index would be k, comma, and my end index would be length minus 1. So now what I am doing here is, so now in the second part, my start index would be like, my start index should start at t. T is at index 3, so which is equal to k. And I'm running this loop up to length minus 1, up to the end of the string. So now the output should look like HBW. This part of the string we are not doing anything. And here I am trying to swap the elements in this input string, input character array. It would be A, S, D, G, T. And this is our output. This is how in this approach we can able to do in a better, in a better space complexity for solving this kind of given string rotation kind of problems for a given string. So why this approach, the second approach, is better than the first approach here is, so in the first approach, he, every time I'm making a substring, I'm creating a new memory, or I'm taking a new space for that substring. Look at it. First part of the substring, second part, I'm considering second part and making a substring and just concatenating those two. So we are unnecessarily taking an extra memory space. But when you look at this approach, I'm no longer taking any extra space here. I am considering the given input string or an input character array. If the string is given, I will be I will be making hold of those input string into an character array. That would be easy. Like, we have some predefined functions in Java where we can convert the string into character array, and just in that character array only, I'm considering this as s, and just doing manipulations in that character array only. So if you look at it in the first step, in the step 4, I'm returning this output which is stored in s itself. I'm considering the input character array as s, and in the step 5, I'm doing some reversal operations on the first part of the string and storing that. I'm just trying to modify the input string only. I'm not taking an extra space. So in the last step as well, I'm just trying to modify the existing string only. There itself, I'm not going to take an extra space. So definitely approach 2 would be a better approach in terms of space complexity. This is what I want to discuss with you. So technically, when the problems are asked on string based things, like rotations, we can do like this kind of reversal and rotations, or somewhere we can look the problem in this way of approach. Once we are clear with our approach, I believe putting this in code, like writing the code for this, would not be a problem for us. So the thought process which you want to take, which you want to make use of these kind of problems is, try to visualize in such a way that you are trying to reverse the string. Like, whenever the rotation kind of things are asked on string, try to reverse it, and we can able to solve these kind of problems. And definitely this concept, by making use of this concept, in the next video I will be discussing some questions on, like, they will be giving a string something like, the input is, this is my first demo. The question would be something like this. So they have given a string like this. Now what they want is, they want output something like reversing all the words in a given input string. So I want something like demo first my is this. They want the output something like this. So you can try to visualize the things with the approach which we have discussed in this one, like the second approach. Try to reverse this entire string and then reverse that again. But here the key thing is, here the trick is, we need to traverse, or we need to get the part of the strings, or the part of the words, like we need to get the words which we want to reverse it. So that can be, that we can find it out by just checking where the first space or white space character is there. When the white space character is there, then I'm based on that, I'm just checking that. When it is there, then I'm based on that, I'm just making use of a reverse function by passing the start and end indexes approximately. But there should be some boundary cases where we need to handle, like, yeah, all those things will be, we will try to discuss in our next video. Thank you, guys.